Okay, so we have this other example, which says the resultant vector value, is observed to be 75 newtons as shown in the as shown below. Consider the angle being close to the x-axis as 15 degrees. Determine the component of the resultant vector. So this is also a very simple question because we're just going to put the angle here. They are saying it's close to the x-axis, which is 15 degrees. So we've been given the angle to be 15. So we're going to draw our triangle there. Our 90 degrees is going to be there. So if we draw our 90 degrees, which one is going to be our opposite between A, B, and C?
A is opposite.
Yes, and then B is adjacent, C is hypotenuse. So the hypotenuse has been given to be 75 newtons. So let us now quickly find the components A and B. So in the X, we're going to have, so this force in the X, we have it there, force in the Y. And then in the X, since this is the adjacent, the X is the one that is adjacent to the angle. So meaning we're using, from SOHCAHTOA, we're going to use cos, because cos is the one that deals with the hypotenuse, and it's the one that deals with the hypotenuse and the adjacent. So we use cos. So we're going to say cos 15 degrees is equal to what? So cos 15 is equal to the adjacent over the hypotenuse. So the adjacent is the force in the X over the hypotenuse is 75. So when you do the cross multiplication there, the force in the X is therefore going to be equal to, the force in the X is going to be equal to 75 times sine 15 degrees. And the force in the X will therefore be, so we say 75 times sine 15. Oh, sorry, cos 15. I wrote sine there, supposed to be cos. So cos 15. So we have 72.4. So we have 72.4. So this is what we have, newtons. And then we also have the force in the Y. So the force in the Y, we are using sine because this is opposite, and sine is the one that deals with the opposite and the hypotenuse. So we say sine 15 is equal to the opposite. The opposite is what? The force in the Y over the hypotenuse, which is 75. So we cross multiply to find the force in the Y. So when you cross multiply, we're going to have 75 times sine 15. So sine 15 degrees times 75, the force in the Y is giving us what? So sine 15 times 75. It's giving us 19.4. So it's giving us 19.4 newtons. And you guys, these things are simple. Do you know what you can do if you want to prove that your solution is correct? You use the Pythagoras theorem. Yeah, so I'm used to saying Pythagoras identity under trigonometry. We're going to learn that anyway. So we use the Pythagoras theorem to prove this. So if we want to find the force F, we have to find the square root of what? 72.4 squared. Remember the Pythagoras theorem. The Pythagoras theorem that we discussed, we said it's equal to what? We know that the Pythagoras theorem states that F squared is equal to F in the X squared plus F in the Y squared. So to prove this, we square root both sides to see if we're going to get 75. So this and that will cancel. We're just going to remain with F this side. Then this other side will have the square root of what? F in the X squared plus F in the Y squared. And this is what we called the resultant force. So To find f is therefore going to be equal to the square root of what? 72.4 squared plus 19.4 squared. You can try to put that on your calculator. You discover that the answer that you're going to find will be what? 75 newtons. And if you get 75 newtons, it means that our answers are correct. All right, so let's quickly move on. We have another example here, which says, determine the x and y components in the figure below, given that the magnitude of the resultant vector is 55 newtons. So we've been given, sorry, I've just forgotten one thing, direction. Look at the direction of the x component. Where is it? So the force in the x is supposed to be negative because it's towards, I mean, it's moving towards the what? The negative x-axis. Yeah, so I forgot to add the direction there. So the negative shows that it's going towards the x-axis, negative x-axis. And then the f in the y, it's going up. So this one is still in the positive. So this one is still going to be positive. So the direction here is negative. I mean, the solution there should be negative 72.4. All right, so we move on to this one. So this one, we have the angle.
Come again on the direction, how we can see where the direction is moving to.
Okay, this one.
Yes.
So here, we're trying to find, let me do this. Here, we're trying to find the components of what, I mean, we're trying to move this direction. See the arrow here. Have you seen the arrow? That is very important. Yes, it's very important. So the origin is O, and then the arrow there tells us to say we're moving in this direction, right? Yeah, so if that is the direction we're taking, then we have to move from this point. We first have to go there. Then from there, from this side, and then we go up to reach this to reach that point. That's the whole instance of vectors, is to locate a position in space. Yeah, so to locate this position in space, we first have to go this direction, which is the negative x. That's why I had to put a negative in front of 72.4 to show that we're going towards the negative x. And then this one, we're going towards the positive y. The y-axis is this one. So this is the positive y, this is the negative y. So we are going towards the positive y. That's why this 19.4 is positive. So this one, the next question, you are going to see how we're going to determine the direction. You look at the arrow here, the arrow points down. If it was pointing up, we would have done the opposite of what we're going to do. So it's pointing down. So the arrow is pointing down, meaning it's showing us the direction. And this is what makes this, a vector. This is what makes a force as a vector, because it has direction. It's showing us that the direction is this one here. And now, since we know the direction, it means that for us to reach this point, we can either take this direction and go down, or if you want, we can take this direction and go like that. So depending with where the angle is, we can find the solution, and the solutions will be the same. So the person who has taken this direction will take the positive x and then negative y. The person who has taken this is going to take negative y and then positive x. So the answers will still be the same. So if you take this angle, it means that you're going to go this way and then go down. But if you decide to take this angle, if this is the angle that was given, meaning you first have to go down and then go to the right. That is how you take the directions. So now the angle that we've been given is, here, meaning we're going to take this direction and then go down. So this is our 90 is going to be there, meaning the opposite is going to be this side here, which is f in the what? In the y. And then the adjacent is going to be the f in the x. So the one which deals with the adjacent, because we've been given this one as 55 newtons. So the one that is the adjacent to this angle 70 degrees is simply just the force in the what? In the x. So what we do is we say from SOHCAHTOA, the one that deals with the adjacent and the hypotenuse is cos. So we say the cos of 70 is equal to the adjacent over the hypotenuse. So the adjacent is what? The force in the x, and then the hypotenuse is 55. So when you do the cross multiplication there, the force in the x will therefore be equal to cos 70 times 55. So I'm trying to be fast because I want to finish in the time that you told me to finish. So cos 70 times what? Times 55 newtons. So we're saying 55 cos 70. So the force in the x is therefore going to be equal to 18.81. So 18.8 newtons. So we do the same even for the force in the y. So the force in the y is the opposite to this angle this side. So what this means is that we're going to use the one that deals with opposite and hypotenuse is sine. So we're going to say sine. We're going to say sine 70 is equal to, the opposite is the force in the y over the hypotenuse is 55. It has been given to be 55. And then the force in the y will therefore be equal to, when we cross multiply there, we're going to say 55 times 70, and this is going to give us 55 times sine 70 there. It's going to give us, so sine 70 times 55 is giving us 51.68 newtons. So that is the solution. So you can try to prove that using the Pythagoras theorem. All right, sorry for that. I received a call. Okay, so let's quickly do the other questions. So we have this question which says, assume a vector falls in the third quadrant with the magnitude 8 newtons. Draw a free body diagram illustrating the resultant vector, assuming that the angle is close to the x-axis. So this one is simple. They are saying it falls in what? In the third quadrant. So we're going to have something like this. I'm going to draw something like that because I know that this is the first quadrant, this is the second quadrant, this is the third quadrant, this is the fourth quadrant. So the vector falls in this quadrant and its magnitude what is 8 newtons. And then they are saying the angle is close to the x-axis, so the angle is here. Given that the angle is 50 degrees, determine the components of the vector. So this one is also straightforward. Do I need to solve it? Yes, let me show you how to do it. Wait, what did we say here? Again, I forgot to show the what is the directions. So in the y, for the y is supposed to have a negative, supposed to carry a negative because we're going towards the negative y. And then for x, we're going towards the positive x. It's just okay like that. So I forgot to write the negative. Okay, so this one, we've been asked to find the components. So when you check the components, the x is going towards the what? The negative. We're going this side, it's negative. Even the y is also negative. So all the answers that we're going to get here, they are both supposed to be negative. So the x is the x is the adjacent. So the force in the x is going to be what? F cos theta, because it's the adjacent. And then the force in the y is going to be F cos, sine theta, because it's the opposite. And because they are all moving towards the negative, this one is the negative x, this one is in the negative y. So we're going to put negatives in front. So the first one there is going to be, so that is 80. So we're going to have negative 80 cos 50 degrees. Then this one will also be negative 80 sine 50. So you can just punch this on the calculator, even that, then you get the solution. Do we have any questions on this one? You see how simple these things are. Yeah, so we proceed that. Okay, to achieve this, the one is determining the resultant. To achieve this, we have to consider the resultant equation. So this is the resultant equation. And then this this x and this y, these are simply just summation of what? Forces in the x and in the y. So let's look at this example. So we have these two vectors, and they're asking us to determine the value of the resultant vector given in this figure below. So you also have to be careful with the angles, the way they have been placed. It's not always that in the x you use cos, it's not always that in the y you use sine. Sometimes they change. So let us quickly look at this example. So I'm going to resolve the 78 newtons into its x and y components, and also resolve this 100 newtons into its x and y components. And then after doing that, I'll then find the sum of all the x components and the sum of all the y components, and then afterwards find the resultant. So for this 78 newtons, in the x, if I draw a triangle there, the angle is here, and the adjacent, the x is the adjacent. So for 78, fx1, so I'm going to call this f1, this one f2. So fx1 is going to be equal to, so this one is pointing towards the positive x, and it's going to be, since it's the adjacent, we're going to use cos from SOHCAHTOA. From SOHCAHTOA, since it's the adjacent, we're going to use cos. So we're going to say 78 cos what? Cos 30 degrees. And then in the y, this one is going to be, okay, let me do this. And then in the y, so if you have a calculator, you can find for me that one, the first one. And then in the y, we're going to have fy1 is going to be equal to, it's pointing towards the positive y. So the positive y is going to be 78 sine 30 degrees. And we also find fy1 there using the calculator. Okay, let me just put them. The first one is 8.4 newtons. Then the second one would be 78 times sine 30, which is 39 newtons. This one, I think I've made a mistake. 67, supposed to be 67.5. Okay, so we have this one in the x and that one in the y. Then we also do the same here. So if we draw a triangle there, we're going to have a triangle like that. So the 90 is going to be there. So here, if you check the x-axis, the fx2 in the x-axis is what? Is the opposite. So the x is the opposite. So we are going to use sine in the x. So we're going to have 100, which is the hypotenuse, 100 sine what? Sine 50. And it's pointing towards the positive x, so we leave it positive. And then fy is this one here. It's pointing towards the negative y. So we're going to have negative 100, and it's adjacent to the angle 50. So we're going to use cos 50. So our fx2 is going to be equal to, so we say 100 sine 50, 100 sine 50 gives us 76.6. And then our fy2 is negative, so we say cos 50 times 100 gives us 64.3. So this is what we have as our angles. So to find the resultant, so we say find f in the x, the resultant fx is going to be equal to, we add fx1 plus fx2. And then the resultant f in the y is going to be what? fy1 plus fy2. So now let us find the resultant. So the fx1 is going to be equal to, fx1 we found was 67.5. So it says 67.5, then plus fx2. fx2 is 76.6. So this gives the total of, so we have 67.5 plus 76.6. 144.1. So we have 144.1 newtons. So we have newtons. Then we find fy, sorry, this one is not supposed to be fx2. I mean fx, it's just supposed to be fx. So we find f, the resultant force in the x. So this one means summation, meaning we're adding the forces. So we find the forces in the x, I mean in the y, we found in the x, then we also find in the what? In the y. So in the y, we have Fy1. Fy1 is 39 newtons. Then we're adding this to Fy2, which is negative 64.3. So we have a minus there, we have a negative 64.3. Then when you find the summation there, you have 39 minus 64.3. And this gives us negative 25. Negative 25.3 newtons. So to find the resultant, so the resultant, which is FR, we have to say fx squared plus fy squared. So the resultant FR is therefore going to be the root of 144.1, then plus negative 25.3 squared, negative 25.3 squared. And we have to find the solution there. So the solution is simply just 146.3. So the resultant force is 146.3 newtons. So that is the resultant force. So these things are very simple. You just need to take them step by step. All right, so let us quickly look at the next example. So this example has 1, 2, 3, 4. I think they okay.
Teddy.
Yes, I'm getting you.
Okay, so just move. I think we understand that one. Move to the exercise, the classwork. The other one is not that one, because that one is like just the one we're from doing. I think it's a bit straightforward. Yeah, so the class task.
This one?
This one. And the other one.
Okay, let me see. Okay. Okay, it has started counting down. Okay. Instead of me ending things before there was this, let's end the meeting and then you join using the same link.